Welcome back again to Projectile Complete Question on UTM. We start from 1995 to 2024. The first question from 1995, we have two bodies, X and Y, are projected on the same horizontal plane with the same initial speed, but at angle 30 degree and 60 degree respectively to the horizontal, neglecting air resistance. The ratio of range of X and Y is what? So here we have two bodies. Note, we have two bodies which are X and Y. And we are saying that these two bodies are being projected. X is projected with an angle 30 degree, while Y is projected with an angle 60 degree. Now we are looking for what? We are looking for the ratio of the range of X and Y. What we mean by ratio is just like if you use the range of X and divide by the range of Y, whatever it gives you, you're now going to call that number S ratio Y. That becomes your answer. Now, what is the ratio of S? Remember that the formula for ratio is R equals U square sine 2 theta all over G. So we are going to calculate the ratio of S and Y and make it as a division to form what we call the ratio. Now, what are we going to do? We are going to say, therefore, the ratio is equals, we are going to use the ratio of S, which if we want to substitute that, we're going to have U square sine 2 multiplied by, we are working for S, which the theta angle, the angle which is being projected is 30 degree. And we divide it by G, which is unknown. And also we have to divide it again because we're looking for the ratio. We have to divide it again with that range of Y, just like I said here. Now the ratio, the range of Y, we are still going to use this same formula for Y, whereby we have the U square sine 2 multiplied by, here the theta or the angle of projection of Y is 60 degree. And we are dividing it with what? G. If you look closely, you find out that this formula up here, which is numerator, is the formula for the range, and this range belongs to S. And this denominator here is also the formula for range, but this range is the range of Y. So when we work this out and divide it by this other range, we are going to have their ratio, which is the answer we're looking for. Now, furthermore, we are going to have that from here, we are going to have that U square sine 2 times 30 is 60, and sine 30 is going to give us root 3 over 2, and we divide that with G, which is this G over here. We also divide it with another U square. Now sine 2 times 60, 2 times 60 is 120, and sine 120 is root 3 over 2, and we also divide it by a G. Now in this case I could have just do some cancelling out, but because it's a tutorial class, I'm going to show you how it is being done. Now remember that this is the big division sign we have here, which means division, and whatever I have here is numerator and this is the denominator. So I can rewrite this as U, this on top one, U square multiplied by root 3 over 2 all over G. Then this sign I have here will now become divided by the denominator, which is U square times root 3 over 2 all over G. All right, now I cannot work with division. If you could remember, I have to change it to multiplication. Changing it, these signs here are going to swap. G is going to come up and this is going to go down. Now I have U square times root 3, this one here, root 3 over 2 all over G, times, I'm going to change this to multiplication, and this G will come up here all over this U square will come up times root 3 over 2 over G. All right, sorry, the G is no longer there. The G is now the numerator. But what is going to happen? If you look closely, I have G here and G here. This can cancel this, and what again? U square can cancel what? U square. And also root 3 over 2 can cancel root 3 over 2, but I want to bring it out as root 3 over 2. That is, this root 3 multiplied by 1 that is remaining here will give us root 3 over 2, and the 1 remaining here multiplied by root 3 over 2 will also give us divided by root 3 over 2. Now, in this case or in this juncture, this can be able to cancel this, and if you cancel it, you are going to have what? 1 over 1. If you could recall, just like division is also the same thing with ratio, therefore I'm going to have that 1 over 1 is now equals to 1 ratio 1. whereby the range of x is 1 and the range of y is 1. I now have the ratio of the range is 1:1, which is in option A. In the next question, we have that a body is projected from an Earth surface with the intention of letting it escape from the Earth's gravitational field. What is the maximum escape velocity of the body? H in bracket, H radius is 6,400 or 6.4 times 10 raised to power 3 kilometer, and then the acceleration due to gravity is 10 meters per second. Now the question asks you to find the escape velocity. The formula for escape velocity V is given by the root of 2 multiplied by the acceleration due to gravity multiplied by the big R, which is the radius of the Earth. Now from here, you're given that G is equals 10, and you're also given that R, which is the radius of Earth, is 6.4 times 10 raised to power 3. Now substituting the value on this place, so that we're going to have the escape velocity to be 2 times 10 is going to give us 20 going to give us 20 multiplied by the radius of Earth, which is 6.4 times 10 raised to power 3. Now if you work this out, 20 times 6.4 times 10 raised to power 3, and you root it, you're going to have a value of 1131.71. Am I correct, guys? Check if I'm correct. Sorry, there should be 3 here. 0.71. Now this 0.71 is going to be on meter per seconds, whereby if you look at the option given to you, have it to be in kilometer. That is after you work this out. This answer is going to give you, but here we have kilometer per seconds. To change meter per seconds to kilometer per seconds, you divide it by 1000. Dividing it by 1000, you're going to find out that you're going to have an answer which is equals 11.313, and so on and so forth. Now you have to correct to the nearest whole number, which is 11, and this 11 will now be in kilometer per seconds. All right, so look for the option. You have it as option number D. This third question is something else. Look carefully. It said an object is projected from a height of 80 meters above the ground with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. The time of flight is. Now, let me sketch it down first before we go into it. This is the height, and this is the level ground represented as this form. Now, the object was thrown from this height, and we know it's going to fall back to the ground. It's going to fall back to the ground. Now, this is the height by which it was thrown, and here it was thrown to the horizontal and made an angle of 30 degrees to the horizontal. We know that the height which the ball was thrown from is 80 meters, and also there is another height which, if we add it to this other height, it becomes the maximum height. Now, this is the mistake you have to make if you are asked to calculate the time of flight using T equals theta, U sine theta over G, whereby U is the velocity we have as 40 multiplied by sine 30 degree, which is the angle of projection, and divide by 10. Here, if you work this out, 40 multiplied by sine 30 is 0.5 over 10. This is going to give you 40 by 0.5 is going to give you 20 over 10, and this we're going to have is to be 2, and it is 2 seconds. This time you have here is the time, not the maximum time of this object. It is the time from here to here, whereby the time of flight must begin from here to this point here, and then the total time of flight will now begin from here all to this place. So we need to get the other time, which is from here to this place. How are we going to do that? Let's complete and get this other height. This is the first height. Now let's complete and get this other height. How can we get this height over here? Remember that height is equals to, or maximum height is equals to U square sine square theta all over 2G. And this is very much equals to U is 42 and sine 30 sine 30 all to square all over 2 multiplied by 10, which is the acceleration due to gravity, is going to give us 20. All right, here, if you work this out, you're going to have something that looks like this: 40 square multiplied by sine 30 is 0.5. 0.5 raised to the power 2 is 1 all over 20. If you work this out, you're going to have your answer to be 20 meter. Hence, this other height is 20 or 20 meter. And then the vertical component, or the height here is what we have as equals to 80 plus 20, and this is going to give us 100 meter. 100 meter from here back to this place. Now, the time of flight, again, we need to add to this time of flight is the formula of motion, and that formula is gotten from the third formula of motion, which say that x is equals to ut plus half a t squared. Now, because this object is under a vertical motion, the u here will become our vertical component, and the g here, acceleration due to gravity, so the a here will become acceleration due to gravity, which is going to be represented as g, and the s here is going to be our vertical component represented as sy, whereby this one here is the velocity, also known as u. And here, if you look at this here, this is under the vertical component of the velocity, and it is equals to uy is equals to theta is equals to u sine theta. All right, u sine theta, if you plug it here, you're going to have this formula here to look something of this form. The s component, which is equals to vertical velocity component, is now going to be u sine theta, and it is having t beside it plus half gt squared. Now, at maximum height, the velocity becomes 0. So if I plug in 0 here and multiply everything here with 0, it is going to go out. Hence, this vertical component, which is sy, is going to remain 1 over 2 at squared. All right, whereby this a, I could remember it is what? G. Now, if we substitute the value we have here, this s, which is the distance, vertical distance we are seeing here, it is being calculated to be 100. Substituting the value of sy is now going to be what? 100 is equals to half multiplied by g, which is acceleration due to gravity, is 10, and then the time is what you are looking for, multiplied by t squared. In this case, we have that 100 is equals to 1 multiplied by 10 is going to give us 10, and 10 divided by 2 is going to give us 5. Now we're going to have 5t squared, and in this case, this 5 is going to divide the both sides. We're going to have that t squared is much equals to 100 divided by 5, which is going to give us 50. Now we are going to find the square roots of 50 by using this square here and root to the both sides. This cancel this. Now the t is going to be equals to root 50 is going to give us 4 points. Let me check for my book. Root 50 is going to give us 4.5, and then that is the time it's going to take from this place to this other place. The time is going to take from here to here, whereby we have added what total height, which we got to be 100. Now this time here, we're going to add it to what this time we have here. Hence, the time of flight t is equals to 2 plus 4.5. This is the 2 we got at the time of flight from here to here, and this 5.5 is the one we got from here to this place, and here we have it to be 6.5. Now if you look at the option, there is no option correct here. This option is wrong, this is wrong, this is wrong, and this is wrong. So there is no correct option, whereby our answer is 6.5 seconds, and that is the correct answer. Now, whereby you do not have the correct answer on the option, what you need to do is you need to approximate this to what you have as 6. This 6 will now become 7. When as the 7, you come to the option, look for a number that is closer to 7. You can find out that 4 is going to minus 2 from 7, sorry, minus 3 from 7 before you reach 4. And here we have 8 seconds. 8 seconds, just need to add 1 to 7 before you reach 8. So you can choose 8 to be your answer. Assuming 8 is your answer, you're going to choose what? 8. But the correct answer is 6.5 seconds. Hence, you cannot just scroll the question and leave the option without marking. They are still going to find the answer on this option, even though that there is no option correct. So you have to choose anyone. And if by favor they notice that there's no answer correct, they are still going to put it as a bonus mark. But if that is not necessary, make sure you look for an answer that is closer to the number that you have gotten. Also remember that this we add here, it is not the total time of flight. It's not the total time of flight. Total time of flight is not going to be this one times 2. This is just the time of flight from here to this other point. So that's why I should pay very attentive. The next question. Now, this other question says a bullet fired vertically upward from a gun held 2.0 meter above the ground reaches its maximum height in 4.0 seconds. Calculate its initial velocity. So the formula that is going to be more easier and faster to use is the Newton's law of motion, which says that V is equals to U plus AT. Now you have to know that when an object is moving vertically, is going to be acted under gravitational for acceleration due to gravity. Hence this A I mean to say is going to change to be minus g because it is moving against the acceleration due to gravity, and we put g by the side. And again, at maximum height, v is equals to 0. V is equals to 0 at maximum height. Like the question says, above the ground reaches its maximum height. So at that maximum height, the velocity, final velocity will be equals to what? 0. I'm going to put 0 here. All right, now we are looking for the initial velocity, which is what? U. Hence, to make initial velocity of formula is going to come over here and becomes negative U equals negative G multiplied by T. Now, negative U is equals to minus G, which is always going to be 10 meter per second. 10 meter per second. Remove this sign because we are calculating. And the time to reach is 4.0, which is just equals to multiplied by 4. Now, negative U is equals to minus 10 multiplied by 4 is going to give us minus 40. Now, remember that we are not looking for negative U or negative initial velocity. We are just looking for the initial velocity, just U. So, in this case, we divide by negative 1 to cancel this negative. We also divide it in the both sides. So, this cancel this. We now have that U is equals to this negative cancel this negative 40. I mean to put here, divide by 1 is going to give us 40, and this is meter per second. And here we have it as option numbers. In the next question, we have that a projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. So this is the projection of the ball, and as we know, it is going to return back to the level ground. Now, in this level ground, we have what we call the maximum height. Okay, maximum height, and this maximum height is not given. We don't need it, and we are given the angle of projection, which is 30 degrees, and the initial velocity, which is u, is the 300 meter per second. Now, time of flight, which is the time taken to reach its maximum height, is given by t equals u sine theta all over gravitational acceleration due to gravity. So that the time of flight is now going to be equal to what is u? Our u is 300 multiplied by sine 30. Always know this as a science student. and JAMB student that sine 30 is 0.5, and 0.5 means 1 over 2, and 1 over 2 is a half of any number I want to multiply. So if I want to use 300 and multiply by that 0.5, or you can call it 1 over 2, it's going to give me half of 300. So multiply by 0.5 over 10, which is the what? Acceleration to gravity. This is going to give us equals to 300 multiplied by 0.5 means half of what? 300. Half of 300 is 150 over 10. So we have to calculate. So from here, this cancel is 15 over 1 is going to give us 15 seconds. From the option, we have it at option number D. Let's something from this question. It says that a tennis ball is projected horizontally from the top of a vertical cliff 50-meter high with a velocity of 10 meters per second. Find the time it will take the ball to reach the ground. Now, this is the height and this is the ground. When a ball is thrown from a cliff or a height, it is going to fall directly to the ground, whereby we represent this as the level of the cliff, and as the height we're given to be 50 meter. What you have to calculate is the time taken from here to here. When a ball, you have to know that when a ball is released from a height or a certain height, there's nothing like total time of flight. We only have what time of flight from here to the ground, because it is not going to be projected up. Else, you are saying that the ball is projected up, but here it is just being thrown and it's reached to the level ground. It is different from when you say that you project a ball with an angle and the thing now gets back to the ground, whereby you're going to have the time of flight to the maximum height and the time of flight back to the ground. For this expression, the time of flight is given by the root of 2 height over the acceleration due to gravity, whereby here the time of flight is given by u sine theta all over g. That is from here to the maximum height. To calculate the total height, you're now going to times everything you have here by 2. That is here and here equal to the time of flight. So for this expression, it is released from a cliff, so we're using this formula over here. Using this formula, we're going to have that the root of 2 multiplied by the height given to be 50 all over g, which is what? Acceleration due to gravity is 10. Sorry, let's press with 10. We are going to have that the root of 2 times 50 is 100, and 100 over 10 is going to give us root 10. All right, and then root 10 is going to give us the expression of 3.16 something, and that is measured in seconds. If you check it back from the option, we have it to be option number D. Second to last question, we have an object is projected at 30 degrees to the horizontal with a velocity of 30 meters per second. What is the maximum height attained? So this is the sketch here. So when an object is projected at an angle of 30 meters to the horizontal, 30 degrees to the horizontal with a velocity of 20 meters per second. So the initial velocity is 20 meters per second, and this is the maximum height attained, and that is what we wish to calculate. Remember that at this point the velocity is becoming 0, so that from what we know that maximum height, you have to have this formula offhand. Maximum height is equals to u square sine square theta, all right, is over 2g. That is for maximum height. Now here we are going to have that h is equals, y du is the velocity given here as 20. We have 20 square multiplied by sine square theta is 30 degree all over 2 multiplied by 10. Here I'm going to have h is equals to this raised to power 2. 2 raised to power 2 is 4. 0 raised to power 2, we put the 0 zeros, and we multiply it by sine 30 in bracket to square. That's what you're going to do over here. And you divide it by 2 times 10, we give you 20. Now what you have next is h is equals to sine 30 is 0.5, and 0.5 means 1 over 2 in fraction. So 1 over 2 is half, and that you now say that half raised to power 2, that is 0.5 times 0.5 will give you 1 in this place here, and this 1 multiplied by 400 is going to give us 400 over 20. This cancel this. We are going to have h is equals to 40 raised divided by 2 is going to give us 20 meter, and that is the expression we have over here in option B. This is the formula for maximum height. Now the formula for range, range is the distance from here to this place is given by R is equals to U square sine 2 theta over G. Here it is 2 theta and here it is sine square theta. They are different in here. You must times the theta by 2 before you sign it, all right? But here, after you have signed, you now square it, all right? So that is the difference.